Okay, I'm going to get started here. As usual, the present in Teams button isn't working, so I'm going to have to share my whole screen. Apologies, maybe Tracy could confirm if everyone seems to be able to see it on the widescreen.
I will do. I can see it. You might need to do a little zooming once you get into it.
Okay, is it coming through too wide?
No, it's your text might be slightly small on this view, so you may have to just zoom in a little bit when you're showing slides.
Okay, perfect. All right, let's jump into it. A lot to cover today. I'm going to get started with a quick platform overview for anyone that may be new to Look, to give you an idea of what we do. Just a quick blurb about us. We have three main components to our platform, three main products. We have our QCam, which you can see right there, 4 cameras with a GPS antenna on top. We're fully camera-based technology, so no LiDAR. You capture with that, you upload it, it gets processed into our cloud processing environment, which we refer to as QAI. And then we make the final data artifacts available for you on our web application, which we refer to as QApp, where you can kind of interact, collaborate, and use your data there. But the most important part, I mean, from going on is the field capture component. If you don't capture the data properly, you're not going to get the accuracy or density or coverage that you need. And it doesn't matter how great our end tools are because you won't have what you need to do your job. So that's the focus today. We're going to be focused primarily on how Look works in the field, do's and don'ts, things to avoid. We'll spend a little bit of time on base stations and ground control points, which do come up from time to time. And then finally, we'll have a little bit of time for questions there at the end. Okay, so Look field capture. For recap, what's in the case? When you open up your QCam for the first time, this is what you should see. Important thing to note here, I think, is the battery. So we do send it out with one battery, which gets you about 3 to 4 hours. But it is just, you can purchase more yourself, and we can share the link for you to do that on Amazon. And if you have 3 of them, that gets you a full day. So, 3 to 4 hours each. If you have 3 batteries, you can kind of hot swap them out as you go. And you can do a full day in the field. So that's kind of the most important thing to note there. And then general best practices. I got my QCam here. I'll hold it up so you can see it. When you're out in the field doing your capture, you want to kind of hold it like a cup of coffee. So you can walk quickly. That was one of the things that if any of you were at our user conference this week, that was one of the things that came up in discussion a lot, which is the walking speed. So you can move fairly efficiently around a site. In general, it's better to move at a brisk walking pace and get more coverage than it is to move slower and do fewer passes. So if you have a building or kind of an environment, let's say that you want to capture that's more of a topographic mapping kind of square area, it's best to move fairly efficiently around it and try to get more pictures of different areas, all while kind of holding the QCam fairly steadily. We do want it pointing up most of the time so that it has a good view of the sky and can see as many satellites as possible. That being said, you can turn it upside down. It does still work this way. Obviously, when I turn it upside down, I'm not getting any GPS. So if you do that, we recommend, having it up at the beginning and the end. And when you turn it upside down, try to turn it carefully. If you have it attached to the end of a pole, it's really quickly to swing it around. But that movement is much quicker, than a human would go when they were kind of walking. So that is something that can result in kind of blurry imagery or lack of matching features between different passes. So can invert it, just do so a little bit more carefully. You want to walk kind of at a mild to brisk pace, and then to snake around, so move around as much as possible. Avoid anything that's going to make the QCam jerk around like that, or like I said, a fast turn where you kind of spin it down like that. You want to have it pointed ahead, kind of held out in front of you like so. Avoid turning it like this where your body is blocking one of the cameras or getting too close. So that's kind of on a high level. Um, we're going to dive into some kind of specific capture examples and how we would do those, and then some kind of common things. So we have bumped up our capture times. You may have been familiar with previously. We were at 20 minutes. Now we're up to 30. So you can go a bit longer in the field, but for really large captures, you still have to tile it. Like I said, we'll dive into some specific examples there. We'll touch quickly on local BPJ base stations, how that impacts the accuracy, ground control points, and weather as well. So number one, or number two, how you walk matters. So this is something that's specifically important for power line captures, or anything where you're trying to reconstruct a really thin feature. If you really just care about the ground, you're doing a topographic survey, it's beneficial to do the S pattern, but it's not necessary. You can still get the coverage you need from straight line passes. But if you're trying to get a really thin feature like a power line, then we would really recommend adding that S pattern to your path. And what does that look like? That just looks like you keeping the camera pointed straight ahead of you and then walking in an S shape. And the main reason for that is we want to get as many pictures from the different cameras as possible of the thin features like power lines. So when you're walking like that, you're not just getting all the pictures from the one side camera, you're getting pictures from all four, your capture path. And that will help with power line reconstruction. In general, like I mentioned, over capture, if you've gone all the way out to an area that you're going to do a look capture with, and you can do it in 5 minutes or 10 minutes, we always recommend take that extra couple minutes, get more coverage of the site, loop around things an extra couple times, and that will really make sure that you get the density and the accuracy that you need. So in general, try to avoid those single passes, and circle around the objects that you care about. So ground control point, you want to circle around that as well. And then try to get loop closure whenever possible too. So when you're operating on ground in kind of a pedestrian environment, as you are with the look technology, although we do have a high accuracy antenna and GPS receiver built in there, you're going to find that you're often passing in and out of high multipath areas. So under trees, near buildings and whatnot. Sometimes you'll be out in the open, you'll get a great view of the sky, you'll get very good accuracy in your GPS, and other times not so much. So getting that loop closure really helps because it allows us to balance out the errors between the areas where you have good GPS and where you don't. And it just helps ensure that you get the accuracy that you need for a capture, especially for our kind of survey customers who want relative accuracy from one end of the site to the other and care more about kind of the global positioning part of it as well. So for some distribution applications, it can make sense if you're specifically focused on the accuracy of how high is this thing up on the pole. But in general, if you're looking for the highest accuracy result, you want to get that loop closure just to make sure that you don't have any drift, and so that we can kind of balance everything out throughout the capture. So site surveys, this is an example that we reviewed. You can see it's a good one because there's kind of a wide open area up top, and then there's a building down below. So when you take a look at this site, we have a wide open area. That means we want to get good coverage of it. So we want to do that lawnmower pass back and forth. You can see the operators kind of walk back and forth across the site. They've got the S-turns in there. They've got their foreground control points. They're circling around each one. Make sure you want to circle around them with the center camera pointed at it. And then we have a building down below, which they've also circled around. So when you have a building in your capture, you want to make sure that you're able to get all the way around it, just so that you don't kind of have those hanging ends there. You want to get that kind of tight loop closure there. Moving on to linear corridors. This is something that comes up a lot. So one of the most common applications for technology in the survey side of things are these linear corridors. So you want to get the sidewalk, you care about curbs, you care about the road, and what is the best way to do that? One of the most common things that we see that we would recommend not doing is when you have a large area, is capturing on one side of the road, ending that capture, and then going over and capturing on the other side. So that is probably the worst possible way to collect a capture with look technology. And the reason for that is when you have separate captures, one on either side of the road, they're processed independently. So you don't get the benefit of having both passes. So you're going to have a lower reconstruction on the road. You're not going to get full coverage there. And you're not going to get the benefit of the loop closure for the accuracy. So if you're looking at a linear corridor, make sure you get both sides of the road and split it up. This way, you can see we got 3 captures here. They're getting both sides of the road there as well as the median when possible with a little bit of overlap between them, as opposed to one long capture on the north side and then one long capture on the south side. Also, you can see they've got multiple passes here. They got one pass where they're focused on getting the sidewalk, any spray paint or any features that may be there on the sidewalk, and then another pass that's a bit more focused on picking up the curb. So you want to make sure that the curb is not obscured. If you're just walking on the sidewalk, you're not going to get pictures of the face of the curb, right? So that's not going to be in your data. And you're going to be a little bit farther from the road, so you may not get a full reconstruction there. So we would definitely recommend getting the sidewalk, then getting a bit closer to the curb, walk the median if you can. So 1, it helps with your coverage, and 2, you have matching features between the different passes on either side of the road. So that's kind of one cohesive data set as opposed to separate ones. And then 2, we got a very nice ground control layout here. You got 4 points there. And then when they move on to their next capture, they're going to start it over here. So they pick up, those same 2 ground control points. So you may need 4 ground control points per capture. You may end up deciding to go with that, but you can actually reuse 2 of them for your next capture if you're doing this linear roadway style. And it ends up looking something like this. So we got 3 captures. Let's say you place 4 ground control each, reusing 2. You wouldn't need, whatever, the whole 4 times 3, because you could kind of reuse them for both. So quick recap, linear surveys, you want to plan it out accordingly. You probably want to plan your ground control placement and your capture lengths before. You want to get both sides of the road, cross over as much as possible whenever you can, and get a little overlap between the 2. There's capture 1, capture 2, capture 3. And that'll get you a successful road capture. Also, quick shout out, thank you to Mac Laney for providing us this sample and letting us use it. Building exteriors, we touched on it briefly, but here's another example. When you're doing a building exterior, make sure you get all the way around. And if you're primarily focused on the building, we do recommend getting 2 passes, generally one a little bit closer so you can get those, foundation corners. Often they want to kind of tie in, building foundations or corners of walkways or things that may be under an overhang a little bit. So you want to get a capture, a pass that's in closer so you get all those little details that you're interested in tying in. Then do a second pass that's a little bit further away from the building, ideally in the opposite direction. 1, it improves your coverage, but 2, it gets you a bit further out from the building. You're going to have better GPS. And so you'll have something to kind of improve the overall absolute accuracy of the data set, while also extending your coverage a little bit further out so you can see some details that are a bit further away. Moving on to manholes. So at the beginning, I touched briefly on, capturing speed. You want to be able to move quickly and efficiently throughout your site. That is primarily applicable to when you have good lighting, right? When we're talking about manholes or vaults or anything where it's going to be a bit darker, you're not going to have as much natural light, the image quality is going to be lower. At that point, you're going to want to move slowly. I won't talk about this too much because our previous webinar was fully on manholes and vaults, so I'd recommend you go check that one out if you're going to do a capture. But just from a high level, if you're going to be turning the QCam upside down and sticking it inside a vault, make sure the LEDs are on. that'll help illuminate the scene, go very slowly. So go very slowly when you're dipping it down. Allow the camera time to adjust to lighting changes. And you can use that same logic for any instance where the light quality is going to be diminished. If you're under a bridge or anything else where it's quite dark, you can always turn on those LEDs. Those are going to kind of flash, give you a little bit more light, help illuminate the scene. And you can move slower to help the camera kind of adjust to it. And then rotate it around, make sure you get good coverage before you pull it back out. So moving on, we've kind of touched on a lot of our main survey applications. So we talked about the roadways, we talked about buildings, kind of commercial residential areas. So now we're going to move on to our overhead utility applications. Those focus primarily around poles and power lines. And we do have a very specific capture recommendation for doing those. So if I'm doing a pole capture, I want to circle around the pole with the center camera pointed right at it, for example. Once, twice, if possible. You want to be able to keep the center camera focused on the pole and circle around it all the way. I generally like to do one circle a little bit closer to the pole. Maybe I'll get the pole tag and other things that are kind of annotated on it there, and then another pass further away to help reconstruct areas at the top of the pole, on the cross arm, any transformers, things like that. Obviously, when operating in a distribution environment, you're not always going to be able to circle all the way around the pole. So if that's the case, do as many semicircles, a couple of semicircles to get as much coverage as you can. We'll be able to reconstruct more than you would think at the top of the pole, assuming you get enough pictures from different angles. Here's the point of interest feature. This is a very common one. It can be hard sometimes. We do collect a lot of imagery, so it can be tough to, figure out exactly where the pole tags are or some points of interest that you may have seen in the field. It can be hard to find those in the back office when you're looking through all the imagery. So if you have something specific, like a pole tag or anything else that you're interested in highlighting for the back office, then definitely do hit the point of interest button that tags it, so that when the technician in the back office comes in, they look at the data, they will see kind of larger green circles indicating there's something here that the fielder was interested in. So it helps them find those images a little bit quicker. So make sure you tag those on the go. And then as you're walking from pole to pole, this is where it's really important to get that swagger, that S path to the distribution or transmission lines that you're trying to reconstruct. So try not to walk directly underneath them, because sometimes one line can block out another one above it. Try to get out. General rule of thumb is, around 3 to 5 paces out. So you'll circle around the pole, then you'll take 3 to 5 paces out away from the power line itself, do your S-shaped pattern, then circle around the pole and keep going that way. And we have lots of examples. You'll be able to see a capture tutorial video on the device itself outlining this before you start your capture. It ends up looking something like this. So I've completed a pole, and then I'm going to continue on in my S path toward the other one. For higher accuracy applications where you can take a little bit more time to do your capture, then that's where loop closure on the overhead utility side comes into play. Or if you need to be able to reconstruct thin features at a higher altitude, such as transmission lines, for example, then we would recommend doing a double pass, which looks like this. So circle around the pole a couple times, get that S shape capture on either side of the power line, 4 to 5 paces out from either one. So the overhead utility captures end up looking similar to the roadway, kind of like this. You plan them out, you'll do kind of around 8 to 10 pulls. Oh, sorry, this is the old one. So it's a bit more now, 30 minutes, and you can kind of get more that 15 to 20 pull range with one pull overlap in between a capture. So here's a common distribution layout. We got 3 captures and they're overlapping by 1 pull each. So we do get a lot of questions about auto base versus local base and ground control points. once again, I'm not going to spend too much time on it because we do have other webinars that cover it. But I think the most important thing to know is that when it comes to accuracy, it's it's very heavily impacted by how close the correction station is. So how do you know? How do you choose? That really depends on your application, and feel free to reach out to us if you have any more questions about that. But on a high level, you turn on the QCam, you walk around, you upload the data, we process it, and we will pull in whatever stations that we can get our hands on to correct that data. In the United States, we're generally pulling from the CORS network. So it varies. So the density definitely varies based on where you are. You could be very close to a core station. You could be very far away from one. So maybe you have one within a couple of miles, and at that point you're getting a very high accuracy. Or maybe you're 1 to 200 miles away from one, in which case you'll kind of get a decreased. So all I'll say on that is that if you want very guaranteed, consistent high accuracy, you can pull at a local base station. If you don't know what that is, reach out. We can recommend a very affordable option. If you're mainly just worried about kind of relative measurements over a short distance, such as height of attachments on a pole, at that point, you probably won't see a super meaningful difference. But if you're interested in, kind of out of the box, consistently high absolute accuracy, where in the world is this positioned, or, accuracy alignment between multiple captures, at that point, I would probably recommend the local base option. Ground control points. This is something that's very important. So you do need a minimum of 3 ground control points for an adjustment. We do a rigid body transformation. So that's going to shift, rotate, and scale. They do try to get good geometric alignment between them. So you can see in this one, we got 4 corners and 1 in the middle. So that's great. For a capture this size, that's more than enough to align it. Don't put them all in a straight line. If your ground control points are all in a straight line, then the whole capture itself can rotate side to side while still technically aligning well with those. So try to get a good distribution of ground control points through your capture when you're using them. And, best to use 4 to 5 at least to get a little redundancy there, as opposed to the bare minimum of 3. Control point types. Try to get a little color. We do get this question. You don't need one that's as big as you would need for a drone or another aerial survey, but do try to get a little bit of color in there so that you can actually make it out in the point cloud. You can use nails, but if you do use a nail, try to get a little piece of flagging or paint or something around it so it pops a little bit more, so that you have a transition between like the grays and browns of concrete or dirt that often are available, and try to avoid getting very similar colors in there. And then when it comes to GCPs, how accuracy do you need them? Once again, depends on your application, but do try to consider the impact that it will have. So if you need very accurate final data, in the 1 to 2 centimeter range, then at that point, maybe pull out your total station as opposed to your GPS. But surveyors, you guys know that already. Okay, what to avoid? Dense vegetation. So look technology, we do rely on being able to match one picture to the next one. It's kind of the core technology that we use to pull everything together in our sensor fusion algorithm, right? We have GPS, we have the IMU, and then we have the camera. Every camera is calibrated in our office, and we really rely on it to get accurate processing. But in a situation like this, you have vegetation, which is not a particularly reliable source of for feature matching, because they can be moving a little bit in the wind. So we often filter them out. So when it comes to a situation like this, there's not really much for us to be matching. Plus, when you get too close, so if a branch or leaves or something come too close to the camera, you can actually end up with motion blur or other issues. So try to avoid dense vegetation, other moving objects. So getting your arm in there to push a branch away, something like that, is not recommended. If you come across a fence, at that point, end the capture, make your way through it and then go to the other side. We've had a couple people try to climb a fence while still capturing, and it's just not the best. And in general, just try to be considerate of the features. So as you're walking through, on the left, you see a nice area with a ton of features, that'll come out well. We'll be able to match one camera to the next. Sorry, on the left. And then on the right, you have a field, so tall, kind of grass that's moving a little bit with a big view of the open sky. So things like that, we tend to struggle with a little bit more. Quick recap, single passes, other narrow areas, getting your arm and stuff in the capture, heavy vegetation, featureless environments. Avoid those things for best possible results with your look capture. Okay, then we got only a couple minutes left. Maybe at this point, I'll open things up. If anyone has any questions or they want to go through, any kind of practical examples, I'm going to stop sharing so I can read them. Okay, question from Caleb. When doing circles or semicircles around a pole, does it help to change the angle of the camera up and down? That's a great question, Caleb. We do get that one a lot. So since we actually have a top camera that's pointing up, it doesn't necessarily help to change it too much. And also when you're doing that, you're actually kind of decreasing the number of satellites that you're seeing because you're kind of turning the GPS antenna away from its open view of the sky. It's actually better to, do a circle around a pole, take a couple of steps back, and then do another kind of a larger circle around it. That's going to get you, some kind of different pictures from different angles of the same feature. If you're doing something like a monument, then at that point, it's beneficial to kind of get it up in the air. So you can change the angle by doing kind of a lower pass and then a second circle, from a higher angle, as opposed to in general, doing different passes while keeping it kind of held consistently is better than doing stuff like that. Okay, so that was the only question in the chat. I'm going to switch over to the Q&A. We don't have any posts yet. All right. Anyone has any other questions, happy to stick around and answer them. We could also, Teresa, if we could unmute anyone if they wanted to ask questions as well. So feel free to raise your hand or, paste in the chat if it would be easier if we could unmute you and you could turn your audio on.
Raise your hand, I'll try to unmute you.
Perfect.
I don't see any hands raised, so I think we're good.
Awesome. Well, thank you so much for joining, everybody. Good to see you all. If you have a specific project you want to talk through or any other questions, feel free to reach out to us, and we're always available, happy to talk through things with you guys. Did Caleb raise his hand? Not sure. Well, oh, there you are. Hey.
No, I was just saying I'm good.
Oh, okay. Good to see you, Caleb. All right. Thanks a lot, everyone. Good to see you all. Thanks for coming to our webinar series. See you in the next one.